We are on the day 20 of the challenge. Let me go and put it here so that it becomes easier for us to navigate. So, yes, on the 20th day of the 30 days, 30 deep learning projects challenge, the problem is to build an autoencoder based anomaly detection system. This is the past part one of the problem where we set up the data and model, and then tomorrow we will be doing fine tuning and evaluate an coder model for anomaly detection. Um, so the flow is going to be same. I'm going to use the same context window of the chat gpt, and here I say, hey, it is day 20 of the challenge, and here is the problem. uh, uh, fine tuning, fine tuning and eva- evaluation we will do tomorrow. So let's wait for the chat GPT to generate the response. Okay. Okay, so let's see, read. So the 20th is day 20 is to build an autoencoder based anomaly detection system. We will approach it with, first we will prepare the data, how we will get the data set, process it, and then split it. Then we will have autoencoder model set up, create an autoencoder neural network to learn the normal data patterns. Okay. And then we will do a training setup where we set the stage for training, but we won't dive into fine tuning or evaluation until tomorrow. Correct. So let's walk through each step in detail, and we will see the explanation. So the step number one is data preparation. For this type of problem, the popular data set to work with is the DKDD Cup 99 1999 dataset, or the credit card fraud dataset from Kaggle. Here we will simulate a dataset for simplicity. So what dataset are we using? I'm just saying, instead of preparing the dataset, can we use the dataset instead? So I'll say, can I just go and check the dataset, network traffic anomaly detection dataset here, and it does not exist. So what I'm going to do, I'm going to use the data set that it says we have used the card fraud detection data set earlier from the Kaggle. So I'm going to use the same one. We have used it in one of our problems from the machine learning challenge. So here we can download the data set. Here it is of 150 MB. Um, and if I check this data set, it has multiple versions, and then at last it talks about whether the, let me go and check out the columns. It has induction to protect user identities, and said okay, it has lot these many data sets. And then it has the v9, where is this the information that whether the user whether the transaction was a fraud one or not. So it contains the transaction made by the credit card in September 2023 by European cardholders. This dataset presents transactions that occurred in 2 days, where we have 492 frauds and 807 transactions. Out of 807 transactions, it is highly unbalanced, with the positive class frauds account for this so data. Okay. Okay, if we go, so let's go and download this data set only. Not this one, but let's download this data. Let me go and check out the one here. If I download, let's go ahead with this one. We have used this data set before. Let's go ahead with this one. This is tried and tested. So I'm going to download it. It has 31 columns, uh, 29 decimals and 2 integers. So let's download. Wait while it gets downloaded. It is going to take oh to my internet speed is not that great right now. What I can do, maybe I have this data set already downloaded. So what I can do, I can, where can I get this data set from? I can go and check the challenges that we have already solved. So here we did anomaly detection. What we have used a credit card data set from this same problem. See the same data set. Okay, it is going to take a lot of time. I'm going to stop it, and I'm using it that I already have it. So where I have already downloaded it, but I have to move. I have to copy this from uh, 30 days ml challenge data set credit card. Here I'm going to get the data set from. Okay, it does not have any data set with C, A, B. Okay, we had dataset dot credit card dot csv, not credit. We had. Let me go and open the files. Which problem it is? It is day 11 problem. I can simply go and get the code from this public repo. Why am I even doing day, not day 13, day 11? And here it is in the data's credit. This is the code. This is the code. So here it has in the this section German loan. Okay, artificial mall. It does. I don't see it here. Strange. If I go and get the data set from here again, let me download it. Okay, now the internet speed is better. Uh, Strange. If I move, go to 30 days ml challenge. Here, go to the data set. We don't have the data. Maybe I have renamed it or I've deleted it. I don't know, but it is funny. I don't have the data set now. It's okay. Let me minimize it. It is it is being downloaded. What we can do, hmm, maybe, yeah, maybe we can wait. So I'll go, come here. Let me go and check. Oh, it is still in the downloading phase. Let me go and pause it again. Okay, so I have downloaded the dataset. I'll go here, unzip it, and then move it to our folder. So let's do that. Let's Let's move from the folder, move from downloads credit card to our dataset folder, and we should have the dataset now. uh, yes, we have it now. So let's start with coding. I'll create a new file, day 20.py. Let's add it to the git repository. Yes, mention what the problem is. Problem is, let's go here. Problem is to build an auto encoder for anomaly detection using the neural network. The data set that we are going ahead with, let's mention that also. So data set is can be downloaded here from here. Now let's come and to the first section, which is to import the libraries. So let's import numpy as numpy, import pandas as pd, import tensorflow as tf. And what all we want to import, we want to import train test split from scalar. We want to import standard scalar, because we want to apply scaling, normalize the data so that they all come in the same range. Then we want to import the sequential model, and then a dense layer. All we have used these packages a lot, so no need to go and understand why they are being used. So model selection, import train test split from sklearn, uh, uh, dot pre-processing, import standard scalar from tensorflow keras dot models, import sequential model from tensorflow keras dot layers, import dense layer. Okay, done with the step number one. Then we are going to load and pre-process the data. So I am doing what, uh, I am going ahead with let's mention it to chat gpt with um, credit card for detection uh, from this. So we are going ahead with that data set. So let's load it. So pre-process, load and pre-process the data, load and pre-process the data. So set, so we'll do what, the data is will be loaded with the panda read csv function. Mention the location, the location is data set and credit card csv. Let's print the data, uh, dot, it is in the data frame form, so let's print the data dot head, and data dot info, not info. What I want to first see the info, and then want to see the first five fields, first five rows of the data. So let's do what, let's run the file day 20. Okay, so we have how many columns? We have 31 columns, and the columns look like V1 version 1, version 2 to version 28. These are all float points, and then we have amount, and then we have class. We have amount, and then we have class. I don't think we would need uh, so this amount is enough. And then we have time also. Time and amount is enough for processing as features to train the model, because this is all encoded. And then we'll have class to tell whether the model is a anomaly model, has fraud or not. So if it is zero, no fraud. It is one, it is a fraudulent transaction. So let's go, let's hide it, and let's build the features and target data set. So feature is going to be data dot drop, the uh, So the columns COLUMNs are going to be time and class are going to be the features, and the y is going to be data dot data only class. So now let's look at the feature featur. This is the correct. So let's look at the x dot head, and let's look at the target. Okay, let's clear the terminal and run it. Okay, so they look like this. This is the data amount, and time has been dropped, and this is the class. Okay, so everything and amount is going to be the feature list, and this is the class. Okay, then we'll do what? So they are already in the range of 0 to 1. The amount can be in the range, can have the larger range, so this can uh, bias the model while being trained, so getting trained. So what we can do, we have to standardize the amount. stand the Standardize amount, uh, column, and other features. So we'll do what? First of all, prepare a prepare scalar. Prepare an object for our standard scalar, and then we are going to fit scalar dot fit transform the features and store it again. Standardize features, standardize standardize amount and other features. Correct. So we have applied standardization, we have applied normalization, that's what we called here. So the range is not that much for any column, any feature or any column here. Now we'll do what? Split training and validation asset into. So we'll have uh, x train, we'll have x validation, y train, and then y validation. Then we'll use test train split to split it into uh, validation and training data set. The test size, which is for the validation data set, is going to be 20%, so we'll go with 0.2. Random state 42 to make sure that whenever we are running the code, it generates the same output. And then what are we doing? Use only non-fraudulent data to train the autoencoder. Okay, so we are using only non-fraudulent data. Non-fraudulent data is a normal data which is going to have the targeted value as 0. So use only non. Why are we doing that? Will maybe I'll get to know later when I'll be using that. We only use non-normal transaction to learn what normal behavior. Okay, so to learn what normal behavior looks like, that is why we are using for autoencoder data. Use only non fraudulent data, which is normal transactions, which is fraudulent transaction for uh, to train autoencoder. So what are we doing? X train normal is going to be x. From x train we only get where the x y train is equals to 0 non, which is a normal transaction, which is not a fraud. Now set up an autoencoder. Now set up an autoencoder. So let's set up the autoencoder. Uh, Set up the autoencoder. So what are we going to do? Model. So we'll say model is going to be a sequential model. Let's add couple of lines so that the code remains in the center. Then we'll have couple of layers. We'll have the encoder will have 14 neurons, then 7 neurons, and then we'll have decoder layers. For encoder, the activation function is going to be rectified linear unit. So yes, then we'll have reduced to 7 neurons. Then we'll decode for back 40 neurons, and then final layer to reconstruct the original shape. Okay, so whatever the shape was there, so we'll reconstruct it and use the linear. So I guess I've missed one thing today. Before starting, I should have asked what is autoencoder and how it works. I felt like it is like what we did yesterday. It was kind of it is going to be something similar, and that is why I did not read a little bit about that. So let's do what. Let me code it a little, because the code is going to be too small. So let's code, and then we can understand what is this autoencoder. So encoder layer, so model dot add a dense layer of 40 neurons. Activation is rectified linear unit, and the input shape is x train x train dot shape, and it will return the, so first returns the number of rows and then the number of columns. So it has number of columns and then this. Once done, then we add model dot second layer, narrow it down to 7 neurons, and the activation function is rectified linear unit. Then we'll have the layer model dot add dense 14 activation function, and it's going to be rectified linear unit. And then we have unsample back to the dense layer the input shape that we have started with. So let's give it back in the same shape that we have received the function, so the neurons, and then the activation function is going to be linear. And then so this is how we are reconstructing the compressed representation back to the original feature size, which is of 30 columns. And then the model is trained to minimize reconstruction error for normal transactions. Okay, so now let's compile the model. Model dot compile, optimizer is Adam, uh, loss is mean square error, and then we train the model and store the training data into history. So model dot fit use x train, as we have mentioned, we are going to train it on the normal transactions, and then we'll say y train. Okay, we are mentioning the same x train model. No idea why. Maybe when we'll be understanding the the ifs and buts about the encoder, we'll get understand. If not, I'll come back to this line also. Batch size. So we are going a little differently today. I guess I misread or misunderstood the complexity of this word, 0 point autoencoder word. So we are splitting 0.20% of data as the normal for the validation, And then we want to see it being trained. Yes, we want to see the training information on the for each epoch on the terminal. And then visualize the training loss. So let's visualize it. So the loss is better. So we have not imported the correct library for it. Let me go here. I have not imported the library. So library is going to be matplot or pyplot as plt. Let's come back and use that. So give a figure of size 10 is to 6, and then plot history history loss, and then label is going to be training loss, and then plot history validation loss. Label is going to be validation loss, and then x label is going to be epoch, y label is going to be the loss mean square error, or we want to see which line represents what with this function. The title is training and validation loss, and then we simply show it. Let's let's now minimize this thing. Sorry, let's go back here. Increase the size, and let's run it to see what it looks like. So we have 50 epochs. It is each is taking on an average 1 second. So loss started with 0.76. We are measuring only the loss. I have many questions from the code, but I am just relying on to see. Uh, so this is the graph is really good. It is not. It is there is very quick decrease in the loss, which is idle, and then for validation there is steadiness and gradually decreasing, and then for training also it is decreasing. So that is good. So the model is performing really good. Uh, but my question is that uh, what are we doing and why are we doing? I don't have idea why are we doing and what are we doing today. So it says that we are going to do fine tune tomorrow, and we are going to use reconstruction error to detect anomalies. So we have not performed or touched the fraudulent transactions, the where we are going to detect whether yeah. So that we have not touched, and I want to know why we have not touched that. So let's understand that. Okay, so I did ask the questions from the chat GPT, as in what is autoencoder, why and where to use it. Also, the things that we encountered when we were coding is why we are using linear activation, and why we are using 14 neurons. If we look at the code, why we are using 14 neurons while encoding, and then why we are using again 14 encode neurons when we decode it, and why we are using linear activation function, and why we are not using the accuracy here. So, and why we are not using the x test, y test, sorry, x validation, y validation, and y train. So all of those questions, the answer to those questions lies into how auto encoder works and what is it. So, how autoencoder works? It is a type of neural network that is used to learn an efficient encoding of or compression of the data. So how it works, we compress the data and then we reconstruct the data. The compression is called as encoding, where what it does, it compresses the input into a small representation called as latent space or code. For example, if we start with 30 features, we started with 30 columns or 30 features in the dataset, and then those features reduces to fewer numbers, that is 7, and retaining the most important information. That is what has happened here when we were encoding it, keeping the important information, retaining the important information. We are reducing the dimensions from 30 features to 7 features. Okay, now in the decoder, what we are doing, we are reconstructing. We take the compressed representation. What we are doing, we are taking the compressed representation and then we are reconstructing. We are reconstructing to the original input. And now what will happen, if the loss while reconstructing is huge, there are two chances. If the loss while reconstructing is huge, or the loss while reconstructing is not that much. If the loss while reconstructing is not that much, which means it is categorized into the data that we are passing while training. What type of data we are passing while training? If we look at the data, we are passing only the train model normal, which is the normal transactions, which are the non fraudulent transactions. So if the loss is less, which means the model is able to reconstruct the input well, which means the input is a normal type of transaction. If the loss is huge, it means the model was not able to reconstruct more, the model was not able to find the patterns, the model was not able to find the patterns of the non fraudulent transaction. So which means it is an anomaly. That is why we are doing so much, we are not using accuracy here, we are doing this here, and that is why. And one more thing, here we have not evaluated the if you look at the thing, tomorrow we, if we not here, if we'll go and check, tomorrow we have to do fine tune and evaluate the autoencoder. We are not evaluating, that is why we are not using the test data set, that is why we are not using the validation data set, the X validation, the Y validation, and the Y tree. We will use it tomorrow when we will be doing what? When we will be evaluating the model. So, this is why we have done what we have done today. And one more thing, what are the other use cases where an autoencoder can be used? One more thing, why the linear activation is used? One more question, why the linear activation was used? Because here, because linear activation is used, if we go and check, we have had problems, not here, if we go here, if we go here, we have had problems like experimenting, understanding the activation functions. So we saw that there is an activation function called linear. This activation function is used when we want to output the values in integer values, that is not 0 and 1, but we want to output the values in the in all the integer possible values. So that is why we are going ahead with linear. Okay, we want yeah. So we have addressed all the answers. One last thing that I wanted to share is that what are the other use cases where this autoencoder can be used, is that this compression thing can be used when we want to reduce the dimensions, when we want to reduce the noise. So autoencoder can be trained to remove the noise from the data by learning to reconstruct clean versions, and then anomaly detection that we have just understood. So it makes sense why we did and whatever we did today. Now we'll come back tomorrow and do what? Evaluate the model and fine tune the model. Thank you very much.